And now for today's program, I'm going to introduce Joe Rao. And if you heard us chit-chatting before, it started with the fact that my children, when they went off to school, would have to wait until I listened to Joe Rao every morning so I would know exactly what they had to wear to school, because I lived and breathed by Joe Rao's forecast. So I thank you from the bottom of my heart for many, many years of working as the meteorologist for News Channel 12. And now let me just tell you a bit about Joe Rao. Joe Rao serves as an instructor and guest lecturer at New York's Hayden Planetarium. He writes about astronomy for Natural History magazine, the Farmer's Almanac, and other publications. And he was an ongoing meteorologist for Verizon Fios One News in New York's Lower Hudson Valley. So please welcome Joe Rao.
Thank you. Thank you very, very much. And a very pleasant good afternoon. And I think I have a feeling that we're going to be seeing more people come in as the talk progresses because it is hot outside. This
It
is one
is
of those
hot.
days. This is one of those days where you can break a sweat 5 minutes after you step outside. So what we're going to do is we're going to talk about a cool celestial event that is coming up on Thursday of this week. And hopefully the weather will cooperate so that we'll all be able to go out and see it. So what I'm
Um,
going to do, yeah,
Joe,
go on.
if I may interrupt for 1 minute, I just say if anybody has any questions, please type
Yes.
them in the chat function, and I will read them to Joe. Thank you. Sorry, I had to interrupt.
No problem. I'm very happy at the end of the talk to take any and all questions, if not about the eclipse or eclipses, but anything else you might have in your mind in terms of science or astronomy or meteorology, which is my advocation. Anyway, let me very quickly share my screen. This is going to be a PowerPoint presentation. I got to tell you something. I'm beginning to really love PowerPoint because you're talking to a guy who not too long ago was still doing slide talks using an old ectographic slide projector. So I'm only just getting now into the feel of PowerPoint, and it's really very interesting and very good. So what you're seeing on the screen, I hope all of you are seeing on the screen right now, is our nearest neighbor in space, and that, of course, is the moon. 250,000 miles away from us, and also the object that illuminates our sky during the dark of night. And people hundreds and thousands of years ago thought of the moon not as a satellite orbiting the Earth, but as a goddess. And that goddess's name was Selene. And Selene, the goddess of the moon of the night. And also during the day, the most important of all celestial objects was this object right here. And that, of course, is the sun. What a wonderful object. It's a tremendously hot ball of gas, as you all know, 864,000 miles across, the part we see normally. All gas from its surface to its center, gas clear into its entirely hot central regions, 11,000 degrees on the surface, almost 30 million degrees at its center. You think it's hot outside? Imagine being in the interior of the sun. It is a star, the closest star relative to us, a star in the middle of our system of planets, the solar system. But hundreds and thousands of years ago, the sun, like the moon, was thought to be a god. In this case, the god Apollo. Apollo would, in his chariot, appear above the horizon in the east in the morning and carry the sun in his chariot across the sky, reaching its high point midway in the sky around right now, around the middle part of the day, and then descend down toward the west and finally disappearing beyond the western horizon. So the sun and the moon were very important. And we had to treat them, at least we tried to treat them with tender, loving care, because especially in the case of the sun, we knew. How many of you have ever thought about this? How many of you have ever thought that without that sun, none of us would be here? That was something that was on the minds of many people, again, hundreds and thousands of years ago. So if anything happened to the sun, oh, that was a time to dread. There are stories, the oldest of these stories going back 41 centuries to the time of ancient China in the Chinese chronicles. I want to read you what we believe is the oldest story, going back again some 41 centuries. And the story reads this way: the day was bright. The great sun hung motionless in the sky above the Yangtze Valley. The Chinese storyteller records what happened next. The dragon Lung, restless with hunger, appeared, and before the eyes of the frightened people, Lung began to devour the sun. The day grew darker. People raised a din, a chant, prayers. The dragon was startled. The sun slipped from his jaws, and Lung vanished to await another chance. Our computers give us the date. It was October 22nd in the year 2137 BC. Now, China back then, all those years ago, had court astronomers. You see them here. Hai on the left and Ho on the right. They're not really astronomers in the same way that we have astronomers today. They were unable to make predictions, but what their job was to look into the sky during the nighttime and take note of anything that was unusual, like a meteor shower or a comet. They called comets broom stars or hairy stars, or stars that suddenly appeared and then suddenly, just as suddenly, over a few days disappeared. Nova, new stars. But the most important thing to keep watch of was when the moon, and especially in the daytime, the sun, seemed to be diminishing, seemed to be losing their light. That was the signal that something up there, a more powerful, invisible source than either the moon or the sun, was devouring and taking it away. And again, in Chinese legend, it was a dragon, Lung. Well, unfortunately, and they would make their observations, they would warn the people, tell them, "Oh, yeah, we got to do something, we got to scare away the dragon." Unfortunately, in this particular case, Hai and Ho were derelict in their duties. The night before the eclipse, they had a little bit of maybe a celebration. They had a little bit too much to drink. They imbibed a little bit too much, and so come the day or the afternoon of the eclipse, they were, to say the least, intoxicated. So much so that no one was warned about the eclipse. Everybody started seeing the sky grow dark and the sun was diminishing. And so the people on their own had to chant and scream and pray and shoot rockets up toward the sun to chase away the dragon. And after the eclipse was over, oh dear. Oh, Hai and Ho had to face the ultimate sacrifice. The Emperor of Japan the Emperor of China, I should say, telling them, "You're going to have to pay because you were derelict in your duties." And pay they did with their lives. They were decapitated, uh, off with their heads. That was the price that they had to pay, Hai and Ho, for again not warning anybody about what was happening to the sun on that particular day, way back in 2137 BC. So, as you can get the idea, eclipses were very frightening to not just the Chinese, but to all ancient peoples. Whenever there was an eclipse of the sun or the moon, people looked up to the sky, chanted, screamed, tried their best to chase away whatever celestial object or being was devouring the sun or the moon. Other cultures, besides a dragon, may have thought it was a pig or a goat or something like that. But the bottom line is, it was a very frightening time, an eclipse. Now, you've probably noticed we don't get eclipses very often. It doesn't happen too often. We're going to have one this week. But why is it that we don't have one more frequently? The reason is that the orbit of the moon that you see here is tilted relative to the orbit of the Earth. So the Earth moves around the sun in a specific orbital plane. The moon is not in the same plane. It's either a little above or below that orbital plane by an amount of about 5 degrees. So what does that mean? That means that when we have the moon pass new moon phase, when it's in the same vicinity of the sun, more often than not, the moon will either pass above the sun to the north or below the sun to the south. Every once in a while, however, there will come a time when the moon's path will cause it to pass partially or completely in front of the sun. When that happens, we have an eclipse. There's a very lovely limerick or axiom about this, and it goes something like this. Sometimes I think of the sun and moon as lovers who rarely meet, always chase, and almost always miss one another. But once in a while they do catch up and they kiss, and the world stares in awe of their eclipse. So, for those few moments when Selene and Apollo get together and kiss, and an eclipse occurs, we here on the Earth watch that rendezvous with our special instruments, our telescopes, and whatever, because it is an amazing sight. But again, because of the tilt of the orbit of the moon relative to the Earth, it doesn't happen often, because more often than not, the moon will either pass above or below the sun, missing the sun, or when it's a full moon passing above or below the shadow of the Earth, and we miss out on an eclipse of the moon. But a very interesting thing was happening. As I said, it was the job of Hi and Ho to record everything they saw in the sky. Other cultures did that as well. Here you see a Babylonian tablet, and while I understand that you don't understand Babylonian, don't understand what's going on here, this was a record of an eclipse of the sun around the year 1000 BC. And what started happening was that as more and more eclipses occurred and more records began to accumulate, the people who studied these records began to notice that, hey, wait a minute, there's a rhyme and reason to this. These things are not happening out of happenstance. They're not happening, all of a sudden for no reason. There is a reason. There's a cycle that's going on. And once the cycle was determined, then we had people who were able to make predictions about when eclipses were to occur. Take a look at this. We all have seen this at one time or another. Located just outside of Salisbury in England, built probably around the year 1500 BC. This, of course, is Stonehenge. And every once in a while during this talk, by the way, I'm going to pause for a few seconds to take a swig of Poland Spring, which I made especially cool since it's a hot day. So if you don't mind, let me take a swig right now. Anyway, so this is Stonehenge. What was it used for? Why did the ancient English build this monument? This is apparently is what it was like when it was brand new in 1500 BC, and it had apparently several purposes. One purpose was to tell the start of the seasons. Did you know that there was a stone in the middle of Stonehenge here? They called it the keel stone, and once a year, on the day of the summer solstice, the sun would appear to rise above that keel stone. So they used it to mark off when the seasons began. They also used it to note when the sun would rise or where the sun would set in the sky. Notice also around the periphery of the Stonehenge, the main monument, there are these holes. What are these holes? These are called Aubrey holes, and they were used kind of like as markers. And they would put stones in the Aubrey stones to mark off certain events. Like, for example, with the moon, they would move the moon marker 2 holes every day. For the sun, they would move that sun marker from one of these Aubrey holes 2 holes every 13 days. But of course, they also noticed that there would be those times when the moon would seem to cross the orbital plane of the Earth. When it crossed the plane, it was called a node. And if it was crossing going from south to north, they called that an ascending node. And if it was dropping from north to south, they called that a descending node. They would move that marker 3 holes every year. And the fact that they were moving these markers in correspondence with when the moon was at a certain node suggests that Stonehenge was also kind of a computer to try to compute or calculate when eclipses were going to take place. Let me tell you that if you had the ability to predict when and where an eclipse was going to occur, or even when the sun, moon, and planets were going to be in a particular part of the sky, you wielded power. And I suppose that, well, I don't know how many of you each day you live by looking in your local newspaper, the Journal News, the Daily News, the Post. You look and specifically look for today's horoscope. And what does that horoscope say for me? Well, quite frankly, as a scientist, as an atmospheric scientist, and also as an associate astronomer at the Hayden Planetarium, I, for one, cannot understand how people would actually believe that the positions of, let's say, Mars relative to Jupiter, or where the moon is in a certain sign in the sky, or where the sun is located. I can't understand how people would think that that would have an impact on their lives, or on the lives of friends or loved ones, or even on the progression of the country. But that's astrology. And astrology began hundreds and thousands of years ago when these gentlemen that you see here were taking note of what was happening in the sky and began to denote various cycles. And among the cycles was eclipses. If you were, close to the prince or the king or the emperor, and you were able to whisper in their ear, next Thursday there's going to be a darkening of the sun. Well, if you knew that in advance, then you were able to then go through the machinations of preparing for when the dragon was going to come and try to eat the sun or to diminish the moon's light. Again, you wielded power in the kingdom. Saros cycle. What is a Saros? That is a special word that is derived from the Greek repetition. Repetition. We discovered, again, over a span of hundreds and thousands of years of study and collecting observations from past eclipses, we discovered that eclipses recur. They come back, they repeat. And to know that cycle is to know when the next eclipse was going to take place. The cycle runs 18 years, 10 and a third, or 11 and a third days. It depends on how many leap years intervene in that 18-year period, whether we have 4 leap years or 5 leap years. That'll determine whether or not it's a 10 or 11 in the cycle. And it's very much like being, if I may use the analogy, being in Las Vegas in a celestial way. You've been to Las Vegas, or maybe you haven't, but you've seen people play the one-armed bandit. They pull down on the lever and they look for the three tomatoes or the 3 lemons or the 3 cherries. Boom, boom, boom. The Saros cycle basically was just that. It is a combined, it's a combination of 3 different cycles when the moon is going to be either at full phase or new phase. That's the only time you can have an eclipse, is when the moon is full or when the moon is new. To know that, that's important. Also, how close is the moon to us? We're going to talk about that a bit later. Is it closer to us than normal, further away in its orbit than normal? That's an important aspect. And again, another aspect was the knowledge of the cycle itself, of when the moon was going to cross that orbital plane. When was it going to cross or reach that nodal crossing point where the sun happened to be to produce an eclipse? So the knowledge of where the node is, where the phase of the moon is, how far away the moon is, those 3 things come together in that 18-year plus cycle. Let me show you. And you know, the thing about this also, we live in the 21st century. How knowledgeable are we? I mean, we have computers, we have 60-inch television screens, we have everything at our disposal with our phones. We know it all. But you know what? If I were to go on the street, let's say Main Street in Chappaqua, and I were to stop 10 people and ask them this simple question: could you tell me how the moon phases? You know how the moon, you've seen it in your newspaper, the phases of the moon. You may have a calendar that tells you what phase the moon is in this month of June. But I'm asking you, how does the moon do that? How does it phase? How does it go from a thin sliver to a half moon phase to 3/4 to full, and then back to 3/4, half, and crescent? What is the process that allows that to happen? You want to know what? I'll bet you 9 out of 10 people probably couldn't tell me. They probably say, well, let me see it. Well, I know the moon goes around the earth, or does it go around the sun? I don't really know. I learned this in general science. That's probably what I would get the explanation in that question. And yet, here we are in the so-called space age, and people probably couldn't answer that question. And yet people in the so-called stone ages, hundreds and thousands of years ago, were able to figure out when the moon would interact with the sun to cause an eclipse. And we use this Saros cycle even to this very day. The map that you're seeing on your screen now is a map plotting the total eclipse of the sun that took place in 1963, July the 20th. I was a very, very young boy when my grandfather showed me this eclipse from my home base in Throgs Neck, New York back then. And he told me there was an eclipse going on, and I didn't know what an eclipse was, but we watched it that afternoon. I guess that's what got me hooked on science and astronomy. But I want you to look at this map. This area right here on the map, this is where the eclipse is going to be at least a partial eclipse. Part of the sun is going to be eclipsed by the moon in this zone. See these lines? They're very special. This line is the 25% line. This passed over Los Angeles. So on that day, if you were in Los Angeles, you would have seen 25% of the moon covered. No big deal. 25% of the sun covered, I should say. Here's on this line is the 50% line. That passed over Portland, Oregon. Half the sun gets covered. Here's the 75% line. And look at this. This blue path, which is only about 50 miles wide, is the path of totality. This is the zone, this is the path where if you happen to live anywhere along this path, you would see one of the great spectacles of nature, a total eclipse of the sun. Look at the path. It started here over Hokkaido in Japan, moved out over the Pacific Ocean, moved through Alaska, down across Canada, through the state of Maine, and then out over the Atlantic Ocean. Now, again, take a good hard look at the zone of the partial eclipse and how the shadow of the moon interacts with the Earth along this particular path. Okay, according to the Saros cycle, we should see a recurrence of this eclipse, the same zone of partial eclipse, the same shape and path of totality in 18 years. And since that 18-year cycle between that we know of 5 leap years instead of 4, that means we also should add 11 days. So let's see, 18 to 1963, what is that? That's 1981. 11 days to July 20th, that's July 31st. So on July 31st, 1981, we should see the same type of eclipse return and move over the surface of the Earth. And there you go. Look at that. The same type of shape and the same type of configuration. See? Look how the path of totality is determined here, and look how it compares to 18 years later in 1981, and there's the same zone of partial eclipse. But wait a minute, you say, Joe, in 1963, didn't you say it passed over Alaska and Canada and Maine? And it's not doing that here. The shadow path now is starts over the middle of the Middle East, goes across Russia, Siberia, and then moves through China and eventually moves out over the Pacific Ocean and passes to the north of Hawaii. That's not the same thing as in 1963, but remember what I told you about the Saros cycle. 18 years, 11 and 1/3 days, a third of a day. What happens in 1/3 of a day? The Earth turns on its axis 1/3 of the way around, 120 degrees to the east. So if it does that, then when the shadow returns after 18 years, it's going to fall on a completely different region of the globe. In this case, as I said, mostly over Asia, not North America. Now let's do it one more time. Another Saros cycle, okay? 18 years. So we add 18 to 1981. That's what? 1999. 11 more days. Now we're into August 11th of 1999. And don't forget that 1/3 of a day. We're going to rotate the Earth 1/3 of the way around. So now when the shadow, same type of shadow path, same type of region of eclipse recurrens, look what happens. Boom. Again, same type of eclipse path and zone of visibility, but now this time, not over Asia. Now it starts just south of Nova Scotia, continues out over the ocean, and then moves across Europe. I got to tell you something. This was a big thing in Europe. On August 11th of 1999, it was their first total eclipse in almost 40 years. Big news in Europe back then. And then the shadow continues and then finally lifts off the surface of the Earth in India, the subcontinent of India. One more go around. Let's go one more time with the Saros cycle. This time another 18 years. And this time 4 leap years instead of 5 have intervened. So instead of 11 days, we add 10. So it's August 21st, 2017. And again, turn that Earth a third of the way for that extra third of a day. And look at this. Look at this. Again, notice, if you will, the same type of eclipse track, the same type of region of visibility for the partial eclipse, but this time the shadow is now once again interacting with North America. Well, did that in 1963, for goodness sake. Look, here's 1963, and here now is 2017. Now, you remember 2017. Remember 4 years ago, we had the great American solar eclipse. You remember how the shadow moved from coast to coast across America? You remember that. That was just 4 short years ago. And so this eclipse in 2017 is related. It is a relative to the eclipse of 1963 because it has returned to North America and it has returned to the United States. And if you think about that, 54 years cycle, that's another cycle. That's another different cycle. It is called an Exoglimos, the triple Saros. 3 Saros cycles and you come back to the beginning. It is the turning of the wheel. That's what Exoglimos meant. And that cycle amounts to 54 years, 32 days plus or minus 1 day. So 52 years in about a month. This eclipse will return basically to the same part of the world that it was 54 years earlier. Now, I'm not going to ask you to remember Exoglimos. And I'm not going to ask you to remember triple Saros, but I do want you to remember in the back of your mind the number 54. I want you to remember that 54-year cycle because it's become very important later on in our talk, in our presentation, in our study of eclipses. So remember that number, 54. Again, it's going to pop up and become very important a bit later. Now, what the heck is this? This looks like it belongs in the local junkyard, doesn't it? But it is a very, very important artifact. It is the Anticathia Mechanism. The what? The hula woo? It is a computer. This was found buried in Ankara, Turkey, and we looked at it, we examined it, we dated it. It apparently dates back to the year 200 BC. This, believe it or not, is a computer. Yeah, it's a computer. Before your iPhone, before your iPad, for goodness sake, even before Radio Shack came out with the TRS-80 in 1980 with a big 400 baud of memory, this is a computer. We actually have built today replicas of this in various museums and laboratories. This contained 38 gears. It contained a crank. And apparently, when it was in use all those years ago, you turned the crank, the gears would turn, and it would show us the motions of the known celestial bodies. The sun, the moon, the Mercury, Venus, Mars, Jupiter, Saturn, all of these things as you crank the gears. And what is the most amazing thing about this also is that in showing the movements of the sun and the moon, it showed when the moon would pass either above the sun or below the sun. It took into account that tilt of the moon's axis relative to the orbital plane of the Earth. Isn't that amazing? All those years ago in the Stone Age, and they were able to develop a machine to do that and to help predict when eclipses would take place. It just stuff like this just absolutely blows my mind. And indeed, eclipses can be used not just, for power, but it could also be used for sometimes some good can come out of an eclipse. Ancient eclipses, probably the most famous eclipse in ancient times, actually ended a 5-year war between two warring factions, the Lydians and the Medes, out in the Middle East. They were in a fierce battle, and then suddenly and unpredictably, the day was turned into night. There was a total eclipse of the sun, which we now know occurred on May 28th, 585 BC, and it was startling enough to cause both nations to cease hostilities at once. They agreed to a peace treaty and cemented their bond with a double marriage. Wouldn't it be wonderful if we could use eclipses to stop wars in our 21st century world? Well, obviously we can't. We unfortunately know a little bit too much about eclipses now, but not way back then. Back then, an eclipse could actually be used for good. And in this case, it stopped a war. Here's another historical event with an eclipse. And you know this guy. I'm sure you did. You must have learned about him in elementary or grammar school. The guy's name is Cristoforo Colombo, or Christopher Columbus to you. And you know about Christopher Columbus. He sailed the ocean blue in 1492. But that wasn't the only time he sailed the ocean blue. He had not one but 4 voyages that he took to the new land, to the new world, to discover new worlds. And on the 4th voyage in 1503, Columbus found himself stranded on the island which we now know as Jamaica. His ship was damaged beyond repair, and his provisions were now running low. Now, at first, he and his crew were able to get food from the natives in change for tchotchkes, for baubles, for trinkets. I mean, look, you can see how intrigued the natives were. I mean, what is this? It's a bell, and you play with the bell. Give them the bell, you get some food and water. The Jamaicans were at first very happy to help Columbus and his men, and I'm sure Columbus must have thought that a rescue caravel was coming for him in a few days or maybe a few weeks. But as the days turned into weeks, and as the weeks turned into months, the Jamaicans finally just got fed up with Columbus. We're not going to be your slave anymore. Forget it. Find your own food. Get your own water. We're just, that's it. Starve. We don't care what these little things, these little gizmos you're giving to us. And now, as this is happening, Columbus's own crew were ready to turn against him. So faced with the prospect of both starvation and mutiny, the great Italian admiral conceived of an ingenious plan. Now, Columbus knew from his navigational tables that there was a total eclipse of the moon right around the corner coming up. It was going to occur soon after the moon came above the eastern horizon on the last night of February in the year 1504. So he arranged a meeting with the chiefs and priests of the natives on Jamaica. And just before sundown that evening, and just before the moon came up, before the start of the eclipse, he announced to all, one and all, that because he didn't like the way they were treating him and his crew, that Columbus's Christian God, the Almighty, had decided to punish the Jamaicans by permanently removing the moon as a sign of his displeasure. And I got to tell you, Columbus timed his theatrics precisely, because no sooner had he proclaimed the moon's disappearance that the moon popped up above the eastern horizon. And very shortly after that, a bite was taken out of the moon, and the bite grew larger and larger and larger. And I got to tell you something, those natives were terrified. They started running in all directions, bringing food to the ship, bringing water, and pleading with Columbus, please, please stop it. Please, we'll do anything, anything you want. Please just stop the moon from disappearing. We love the moon. The moon gives us light. Please don't take the moon away from us, please. Well, of course, Columbus waited until the moon completely entered the shadow of the earth and became totally eclipsed. And then he calmed the Jamaicans down and said, all right, here's what I'm going to do. I'm going to go back into my cabin and I'm going to intercede on your behalf with my Christian God. And I'm going to try to change his mind. I'm going to try to have him return the moon and place it back up into the sky. But I'm not making any promises. I can't promise you, but if I'm successful, I'll come out and I will tell you. And then he went back into his cabin and he conferred with his God. And who was his God? How many of you remember the movie The Wizard of Oz? You certainly remember late in the movie with the Wicked Witch. You remember that, right? An hourglass. Columbus had one in his cabin. And you know what he was using that hourglass for? To time out the period of total eclipse. And when he knew that the eclipse was just about ready to come to an end, that's when he stepped outside and announced that his God had pardoned them and would allow the moon to return to its rightful place in the sky. Everything was forgiven. All was well. And of course, the Jamaicans were, I'm sure, very, very happy, looking up into the sky, seeing the moon returning, and bowing down to Columbus. I can assure you that Columbus had no more problems with the Jamaicans, who gratefully supplied him and his men with all the food and supplies they needed until they were finally rescued and returned to Europe. But what is the science of eclipses? I've mentioned this word several times in this talk. Shadows. Shadows. That's all it is. That's what it all boils down to. The shadow of the earth, the shadow of the moon. How many of you remember from your days at school the poem by Robert Louis Stevenson, My Little Shadow? I have a little shadow that goes in and out with me. And what could be the use of him is more than I can see. Well, scientists use the shadows of the earth and the moon to help in their calculations of eclipses. And now I want to show you what basically is a microcosm of what happens during an eclipse of the sun. For that, I'm taking you to a very strange location. This is Pac Bell Park in San Francisco, and it was during a playoff game that took place between the San Francisco Giants and the San Francisco Giants and the Washington Nationals. You could see the game was just beginning. Nothing to nothing, 17 pitches in, 2 outs in the top of the first. But something happened in the top of the first that caused the game to briefly halt for a few seconds. And what was that? Why don't we go to the microphone? Let's go to the tape and listen to what the commentators of this playoff game commented on that day of this playoff game a few years back. Here we go.
Be a big pitch for Madison. And with a strange shadow being cast mid-pitch as a result of a blimp or a plane flying overhead. It's 2 balls and a strike to LaRoche. Even Adam had to look up and say, what is going on here? That would be the blimp. The lights went out. No clouds. Beautiful sunny day. It's hard enough to hit Madison Bumgarner.
Well, you saw the shadow, the blimp shadow, as it moved across the field, and to echo what the one of those commentators said, the lights went out. And that is basically the story of eclipses of the sun. Now I'm going to show you a different picture. Now you see there's the shadow of the blimp. Let's look at a different perspective here. Here's another shadow, and this is not a baseball field. This is us. This is the Earth, and that shadow is not a shadow from a blimp. That is the shadow of the moon. That is the shadow of the moon being cast upon the Earth. This picture was taken by a cosmonaut on board the now defunct Mir Russian space station as it was passing over Europe in 1999. Remember in 1999, I told you earlier, it was the first total eclipse of the sun in almost 40 years, big event. And anywhere along the eclipse track that you see here, anywhere in that big dark circular blotch, you would see a total eclipse of the sun. And again, to quote the baseball commentator, the lights went out. And when a total eclipse occurs, indeed, it gets dark enough for you to see shadow of the stars and the planets. It's just an inglorious sight. We'll talk more about that later. First, I want to get into eclipses of the moon, the eclipses that affected Selene. And in this particular case, we have the shadow of the Earth. The shadow of the Earth runs almost 1 million miles in length. Now, the moon is about 250,000 miles away, so there's no problem in getting the moon completely and totally immersed in the shadow of the Earth. Now, you know that the moon doesn't shine on its own. It shines by way of reflected sunlight. The sun gives the moon light. And if we take away the sunlight from the moon, well, the moon goes dark, right? That seems logical. Take away the sunlight, the moon would go black. Well, not necessarily. Here's a composite photo of a lunar eclipse, a total eclipse of the moon, as the moon was passing through the southern part of the shadow of the Earth. In fact, you can even see the shape of the shadow is a sphere or a circle. Only something that's spherical or circular or can cast a circular shadow. So all the people who tell you that the world is flat, you show them this picture and they say, this is fake. It's got to be some other explanation. But that's the explanation, that the sphere of the Earth casts a circular shadow into space and the moon passes through it. But take a look now. I said that when the moon is in the Earth's shadow, in theory, it should black out. But instead, it glows with a ruddy or coppery color. Well, where's that coming from? It's coming from the fact that this Earth of ours has an atmosphere which allows us to live and breathe. Now, when the sun is high in the sky, you remember when you were in Earth science class and your Earth science teacher probably pulled out a triangular piece of glass called a prism. And what did he do? He went up to the window and he let the sunlight shine through the prism. And what did the prism do? It broke that white sunlight into many colors. That's what sunlight is. It is the color of the rainbow of different wavelengths. And so when that sun is high in the sky, as it is right now, the short wavelengths, the wavelength of light, is taking a shorter distance to reach to your eye. So as a result, the short wavelengths are tilted more toward the blue end of the spectrum. That's why we have blue skies during the daytime. Something, a more technical term, is Rayleigh scattering, if you will. You could look that up in our Google after the talk. But when the sun and even the moon get low in the sky and get ready to rise or set, I'm sure you've often seen the orange or red color. And the reason is that now, when the moon and the sun are near to the horizon, the light of the sun is taking a longer trek or distance to get to your eyes. And long wavelengths tend to lean more toward oranges and yellows and reds. So right along the edge, right along the rim of the Earth, right along the horizon is where we find this ruddy or reddish coloration. Now, when you're on the moon during an eclipse of the moon, it is, for those who are on the moon, not an eclipse of the sun. Think about this. You're on the moon. The sun is being blocked out by the Earth. The Earth is coming between the sun and the Earth and blocking out the sunlight from reaching the moon. So when you look up into the sky during a total eclipse of the moon, what are you seeing? You're seeing the dark disk of the Earth 4 times bigger than the way the moon looks to us here on Earth, because the Earth is 4 times bigger than the moon. But instead of completely blacking out, we see around the edge of the Earth, look, the orange and red color of sunrises and sunsets happening at that moment all around the world. And that happens because we have an atmosphere. And the atmosphere acts like a lens and refracts or bends sunlight into the Earth's shadow. And so if you're on the lunar surface, you see this bright orange or reddish ring of light surrounding the Earth, and that red light falls upon the moon and lights the lunar landscape. And that's what you see when you see a total eclipse. You're seeing the moon light up like a red ball because you're seeing the combined light of all the sunrises and sunsets happening at that moment, directed toward the surface of the moon. Now, who can see a total eclipse of the moon? Do you know? Here's a funny thing: total eclipses of the moon are less frequent than total eclipses of the sun. And that may sound strange to you. I'm sure that every one of you at one time or another has seen a total eclipse of the moon. And maybe you've seen more than a few in your lifetime. Yet many of you probably have never seen a total eclipse of the sun. Why is that? Well, we saw that for a total eclipse of the sun, you have to be in a very special place. You have to be along that very narrow corridor, which may be only 50 or 75 or 100 miles wide. And so that's where you have to be for a total eclipse of the sun. But for a total eclipse of the moon, wherever the moon happens to be above the horizon at the time the eclipse is taking place, we'll see that eclipse. That means basically one half of the Earth, the dark side of the Earth, the part of the Earth that's in nighttime, get a chance to see a total eclipse. That means, for example, in this case, if there was a total eclipse going on right now, everybody on the dark side of the Earth, everybody in North America, Central America, South America would be able to see it. I didn't mean that to happen, but I'm going to just bring it back here for just a second. So everybody on the dark side of the Earth. So what we're talking about is not a viewing audience of thousands or millions. We're talking billions, billions on the continents of both North and South and Central America being able to see a total eclipse of the moon. In fact, it's very much like being in a movie theater. I think about this every time I go see a movie. I always think about, hey, this is just like watching a total eclipse of the moon. Think about this now. You go into a movie theater, you sit down. Other people sit down too in the theater. Now, pretend, if you will, that each seat in that theater represents a place. It may be a town or a city in a specific state, or it might be a city or community in a certain country, or on a certain continent like North or South America. And now, as the technician turns down the lights in the theater, now it's like it's nighttime, right? It's being like on the night side of the Earth. Now you're looking up at a blank screen. Nothing's going on that screen. Big deal. That's not fun. But once the movie begins, now you have something that's going to entertain you for the next 2 or 3 hours. You're watching a movie. You're being entertained by that movie. In the sky, pretend that the moon is the movie screen, right? And pretend that when the eclipse is taking place, you're watching a show. You're watching a show of shadow moving across the face of the moon. Not only are you watching a play of different shades of light and dark on the moon, you're also, when the moon is in totality, you see those colors of orange and red in technicolor, if you will. It's just like watching a movie. And again, you on the night side of the Earth are just one of countless millions and billions who are watching that show in the sky, watching the big screen, the moon, at that moment, just like if you were in a movie theater and watching a movie. We had, by the way, a total eclipse of the moon just a week ago. Not this past Wednesday, but the Wednesday before, there was a total eclipse of the moon. And I know that none of you saw it unless you did a little traveling. Because you see, when the eclipse started here in the New York area, guess what? The moon was dropping below the western horizon and the sun was coming up in the east. So it was getting to be daytime. We were now moving into the day side of the Earth. The moon was no longer visible. So we were not able to partake in the total eclipse because it just wasn't visible on our half of the Earth. But if you went to the west of the Mississippi, if you went to California or Montana or Idaho or Colorado, Denver, you would have been able to see it because out there it was still dark while it was becoming light here. They're 2-3 hours in time behind us in Mountain and Pacific time. So it's still dark. The moon was still above the horizon. And so the moon underwent the eclipse while it was still visible. And so people were able to enjoy it out there, out west. We weren't. We were out of the viewpoint of or visibility zone for that eclipse. Now, there's going to be another eclipse of the moon coming up later this year, and a very easy date for you to remember. The date will be the last Friday or the Friday before Thanksgiving, Friday, November 19th. And it's not going to be a total eclipse, but it's going to be almost one. More than 97% of the moon is going to become engulfed in the Earth's shadow. And only a tiny little sliver, the bottom part of the moon, is still going to be outside of the shadow. So this is basically what you're seeing on the screen right now is what you're going to see in the sky during the peak of that eclipse. You'll probably see the reds and orange colorations, and you'll see that edge of the moon still sticking out of the shadow, the last little bit, the 3% that's not going to be in the shadow. And some people, some photographers, call this the Japanese lantern effect because it kind of looks like one of those Japanese lanterns in the sky when you see it. Oh, you're asking, Joe, when do I have to see it? When is it going to take place? Going to get up early, 4:19 a.m. Set your alarm. Get up at 4:19, step outside, bundle up. It's probably going to be a lot colder in November. Look up toward the west where the moon is, and there you'll see the moon engulfed in that shadow. And it should be an eerie and unusual sight. Now, have you noticed also that the moon and the sun seem to be the same size in the sky? I mean, the moon, we know, is a lot smaller than the sun. In fact, I can tell you right now, the sun is 400 times larger than the moon. And yet the moon appears to be the same size as the sun. How is that possible? It's possible because the moon is 250,000 miles away from the Earth. But the Earth is 93 million miles from the sun. So if you take 250,000 and divide it into 93 million, you know what you're going to get? You're going to get the number 400. So the moon may be 400 times smaller than the sun, but it's 400 times closer to us than the sun. So they both appear the same size. And when we put the moon over the sun, it fits exactly and perfectly to cover the entire sun. Well, no, not all the time. You see, the moon doesn't go around the Earth in a perfect circle. It goes around in an elliptical orbit. Sometimes the moon is rather close to the Earth. We call that perigee, 221,000 miles from the Earth. But then 2 weeks later, it moves to the opposite side. Remember, the moon phases over a span of 28 days. So this is to go one way around the orbit is 28 days. So 2 weeks later, 14 days later, the moon moves over to this side of its orbit, and it's at apogee, 253,000 miles away. Now, the variance, the distance between close and far is about 12%. So the moon not only varies by 12% in its distance from the Earth, but also in the sky, because it's sometimes close, sometimes far, what we see in the sky is the moon change size. Not all that much. You know, we're only talking 12%. But on the left, you see the moon at apogee, far from the Earth. And here you see the moon at perigee, when it's close to the Earth. When it's close to the Earth, and when the moon is at full phase, there's a term that has become very popular in recent years. We call that term super moon. You know the super moon. You've heard about that, right? It's the newscasters. Well, tonight, if you go outside, look up at the moon. It's a super moon. Big deal. I mean, come on, give me a break. 12% difference in size between close and large, and you're going to call this a super moon. My boss at the Hayden Planetarium, Neil deGrasse Tyson, says, if I made a pizza 16 inches in diameter, and then I went ahead and made another pizza 16 and a half inches in diameter, would I call that extra half-inch size pizza, would I call that a super pizza? I don't think you would. And so why call this the super moon? But that's the parlance that the news media enjoys using. And I will tell you this. Remember, I just told you we had a total eclipse of the moon a week ago? That was also a super full moon. It was at its closest. But wait a minute. If it was super moon and closest to the Earth at full moon, then that means that 2 weeks later, when we come to new moon phase, it's going to be near the far point of its orbit. And therein lies a very key factor in the upcoming eclipse on Thursday. Here's the diagram showing you how the moon comes between the Earth and the sun. The sun is off the screen. You see the rays of sunlight coming in, hitting the moon on one side. The dark part of the moon, well, casts that long conical shadow. But look at this. It tapers to a cone, tapering off, off. And it gets to this point and comes to an end before it touches the Earth. The shadow does not touch the Earth's surface. It misses us. So what do you do, or what do you see if you happen to be here under the shadow in that red zone, that red ring, you would see this. This is what you would see. You would see a ring around the moon. Because the moon, at its farthest point from the sun, remember I said 400 times smaller, but 400 times closer. Yeah, that works out. But what happens if the moon is a little bit too far from the Earth, as it is during the times of what we call apogee? Then the disk of the moon is not quite big enough to cover the sun completely. Go in your wallet, go in your purse right now and pull out a nickel and a penny. Put the nickel and penny on a table. Now, I challenge you, take that penny, put it on top of the nickel, cover up the nickel. You know what? You're not going to be able to do it because the penny is going to be too small to cover the nickel. In the same fashion, the moon, in the guise of the penny, is going to be much too small to completely cover the sun, which would be in this case the nickel. And so you end up with a ring of sunlight shining around the dark silhouette of the moon, an annulus, derived from the Greek, the Latin term annulus, meaning ring-shaped, which is why we call these type of eclipses annular eclipses. Not annual, they don't come every year, but annular because they form a ring in the sky. And this coming Thursday morning, we are going to see the sight, well, not us here in New York, unfortunately, but folks who properly position themselves are going to see this beautiful sight of the sun being covered by the moon, but not quite, and causing a ring of fire in the sky as the sun is coming up above the horizon. A beautiful sight. And I know not a few people who made plans to see this because you see the eclipse, the path, the zone of the ring phase is going to occur right along this brown zone that you see here. And these ovals, that's the footprint of the central shadow of the moon as it tracks across the Earth. Notice, if you will, it starts just to the north of Lake Superior. People who are along the shorelines of Lake Superior, looking to the east northeast, will see the sun rise, and they will see it as a ring in the sky. What an amazing sight that is going to be. And then we'll continue northward through Hudson Bay and on up through the Ungava Peninsula of Canada. Up here, there's a little tiny town called Pangnirtung. 1,500 Inuit Eskimos live in that village, and they will be treated to the site of the ring eclipse. Cuts off a little piece of Greenland, I should say. And look at this, it's going to go over the North Pole. I certainly hope Santa will give the elves a little time off on Thursday from their toy making to step outside of the castle and enjoy this rare celestial spectacle. And then the shadow will continue around off of the surface of the Earth somewhere in northern and westernmost Siberia. So there you go. You have to position yourself somewhere in here. And I know a lot of people were planning to go right here, just to the north of Lake Superior in northwestern Ontario to see this amazing sight. And I said, people made arrangements. Some people built their vacations around this. And you want to know what? It ain't happening. Now, the eclipse is going to happen, but going to see the eclipse, that ain't happening because this eclipse will be, as you can see, in Canada. And while there are many things that are opening up now in the wake of the pandemic, local stadiums and arenas are opening up. Broadway is going to be opening up in September. Schools are opening up. Stores and restaurants are opening up. But the border between the United States and Canada has not opened up yet. I don't know how many of you read the Daily News. If you saw yesterday's editorial in the Daily News, the Friday editorial, they had some words not too kind for our friends and neighbors to the north. Why haven't you opened up the borders? With the vaccines and everything dropping, still certainly you can open it up now, but Canada remains shut. And so as a result, nobody who lives in the United States will be able to travel to Canada. And so as a result, nobody who lives in the United States will be able to journey to see this rare and spectacular ring or annular eclipse, which will track across the Earth this way. See the red? That's the zone of the central or annular or ring of fire, Johnny Cash. The ring of fire in the sky. And it goes again from Canada across Hudson Bay, right over the North Pole. Boom, there it goes. And then leaves the Earth's surface over Siberia. But this larger zone, see that shadow, that huge shadow, which will cover parts of North America, Greenland, Europe. Europe will be able to see part of the sun covered this coming Thursday morning by that eclipse. And this map is an interesting map. Anyone who lives below this line, see here, anybody who lives below the line will not see the eclipse. Funny, the people who saw the eclipse of the moon about a week ago, they were able to see it. We weren't. Now, guess what's going to happen? The same people who were able to see the lunar eclipse will not be able to enjoy the solar eclipse coming up on Thursday. Now it'll be our turn to enjoy a celestial event, an eclipse event, because the people who live out in the west, again, will not see it, because when the sun rises for them, the eclipse will already be over. So that will not happen if you live out west. Now, here is the line to watch. This line right here from the Atlantic and across up here, you know what that is? That is two things. That is the line that shows you where the sun is going to be rising on Thursday morning. And at the same time that it's rising, the eclipse is going to be reaching its peak. Now, that's a very unusual situation. For example, people who live near this line, you're going to miss the first half of the eclipse. The eclipse will start and gradually progress, but you won't see it because the sun will be below the horizon. And then finally, when the sun comes up above the horizon on Thursday morning, that will be the middle of the eclipse, the greatest part of the eclipse, the maximum of the eclipse. So if you live in Sault Ste. Marie, if you live in Toronto, if you live in Philadelphia or Atlantic City, Asbury Park, New York, Montauk, all of these places where the sun will rise on Thursday morning, well, you're going to see a very unusual sight, a most unusual sight. The most unusual sunrise I think anyone has ever seen in their lifetime. How many times have you done that? Maybe a friend of yours, called you up on the phone. Hey, Charlie, Matilda and I, we're going down to the beach tomorrow to watch the sunrise. You want to come with us? Yeah, sure. Why not? You go down to the beach or whatever, and you watch the sunrise. And this is what you see, the sun coming up as a big orange ball. It looks nice. It really, really is interesting, right? It's such a tranquil period. But on Thursday morning, if we are blessed with clear skies, you ain't going to see this coming above the horizon on Thursday morning next. This is what you're going to see. The sun coming up looking like this. 4/5 of the sun will be covered by the moon. The moon will have interposed itself between the sun and the earth and giving us this view. We build this talk as sunrise scimitar. It's sunrise, and look, the sun certainly looks like a scimitar or a sickle, if you will, or maybe to some of you it looks more like a slice of cantaloupe melon, or maybe some of you may think that it looks more like a horseshoe, an upturned horseshoe with pointed tips. But that's what will greet you next Thursday morning. Now, as we approach the start of summer, let me remind you, sunrise is rather early at this time of the year. Give or take a minute or two, depending upon where you are. Sunrise is at 5:24 a.m. And the peak of the eclipse comes just 8 minutes later, the maximum at 5:32. And the end of the eclipse comes less than an hour later at 6:30. In other words, at 6:30, the sun will be bright and round and full and its normal self once again as the last little bit of the moon moves off the disk of the sun. So if I were you, I'd set my alarm for about 5 a.m. or somewhere around the 5 o'clock hour. And please make sure you don't hit that snooze. You hit the snooze and then you wake up a little bit later. It's like 6:15. You say, oh, wait a minute. I got to see the eclipse. By then, the eclipse is practically over. As you can see, it ends at 6:30. So be up bright and early. Cross your fingers. Let's hope for clear weather for the eclipse. As I have my little birdie sail away. And this is basically what it's going to look like next Thursday morning. We have a little animation I've created here. The cusps, the tips of the crescent are going to come up above the horizon, pointing straight up. And then within the few minutes as we lead to the maximum of the eclipse, this crescent is going to turn to the left. And eventually after the peak of the eclipse, the moon will move off to the left or to the east, and that'll be the end of the eclipse. Watch carefully now as we move up. And as I said, the cusps come straight up, pointing straight up from the horizon, and then they'll turn to the left. There, up, turning. Peak of the eclipse, 80% coverage or thereabouts. All right, sun and moon, you can move on. And the moon continues to move off to the left and off the disk by 6:30. Now, liability, very important here. We don't want anybody to wreck their eyes by looking at the sun during the eclipse. The sun is 400,000 times brighter than the moon. The sun has not only visible radiation, which you see every day, but invisible radiations like infrared and ultraviolet. For goodness sake, ultraviolet is what gives you a sunburn. And the last thing you want is to subject your eyes to those kind of radiations. And so don't be like this dummy here and point a telescope of all things at the sun. And you know, the funny thing is, people say, I hear there's an eclipse coming. I guess the sun is dangerous. We can't look at the sun. They think that the eclipse is the reason why you shouldn't look at the sun. It's wrong. I took a phone call at the Hayden Planetarium for the last eclipse 4 years ago in 2017. This is what the phone call sounded like. All right. Phone rang. I pick it up. Good afternoon, Planetarium. Yeah, hi. I want to ask a question about the eclipse coming up. And I said, yes, sir. What do you want to know? Yeah, I want to know about a specific time. Could you tell me when the eclipse is going to come to an end? And I said, okay, according to our tables, 2:54 p.m. 2:54. 2:54. Let me write that down. 2:54. So, in other words, 2:54, the eclipse is over. That's right, sir. Okay, so after that, I can look at the sun, right? No, no, you don't look at the sun after the eclipse is over because the sun is dangerous all the time. You have to take strict measures and prevent blinding yourself by looking at the sun. So here, for next Thursday morning's eclipse, 3 ways for you to look at it. Here's number 1. How many of you have a mirror, a hand mirror? You ladies have a compact. You must have a mirror with that. Or you guys, you must have a pocket mirror. Use the mirror to watch the eclipse. How can you use that? Let the sunlight hit the mirror and then make the reflection of the mirror fall onto the wall. Now, if you're too close to the wall, if you're, let's say, 4, 5, 6 feet away, the shape of the reflection is going to come out looking exactly like the shape of the mirror, a square image or a rectangular image in this case. But if you move far enough away, 50 or 100 or 150 feet away, for example, that image is going to convert over to a circular image. That circular image is the image of the sun. That is what you'll be looking for or looking at on the wall. If you do that tomorrow morning for the sunrise, or even do it right now, when you finish listening to this lecture, you go outside, use that mirror, again, get far enough away, 50 or 100 feet away, you project a circle. That's the sun. Except next Thursday morning when you try this, instead of getting a circle, you'll get that crescent image. You'll be able to project the image of the sun onto the wall, the eclipse onto the wall. And the best thing about this is using that one single mirror, not just you, but a whole lot of people all around you can look at the image of the sun safely on the wall. Now, let's say you have a telescope. Again, don't do what that guy in the cartoon did. You make a collar or a shade and put it up near the end of the telescope, the large end with the big lens. That's the objective lens. Then you play and do by trial and error, positioning it up toward the sun. Don't look through that eyepiece, but by trial and error, project the image until you see that sun and the light of the sun fall upon a screen, which would be a paper or a piece of cardboard. Now, not only do you have the projected image of the sun and the eclipse, but now you also have a magnified image of the sun on that piece of paper or cardboard. And if there are sunspots or solar blemishes, you will see them projected on that image of the sun. The best way of all are these, which have become very popular. These are eclipse glasses or eclipse shades. And many people ordered these, and maybe some of you who remember the eclipse from 2017, if you can remember where you stowed those glasses, hopefully you didn't throw them away, but if you still have them, use them on Thursday morning to watch this upcoming eclipse. Now, these glasses are made of a special plastic called polymer. They not only block off a large percentage of the visible light, but also the ultraviolet and the infrared, and they are safe to use. You can order these glasses on Amazon. There's also a company, and I do not get anything for mentioning the name of the company. I'll mention to you, however, now, and you can find them on social media. The name of the company is Rainbow Symphony. Rainbow Symphony. They've been making all kinds of novelty glasses for the last 30 years, including eclipse glasses. You can order it from them. But here's the problem. The eclipse is 5 days away. So if you try ordering now, I'm sorry to say, I think that you'll probably see a message on Amazon or on Rainbow Symphonies telling you, we're shipping your eclipse glasses out. You'll have them on June 11th or the 12th or 13th, the day after the eclipse. That's not going to do you any good. So I don't know. You may want to try and see as best you can if you can get your hands on eclipse glasses. And again, if you have any of these, and I know scalpers. There were scalpers who were actually selling these glasses. Now, these glasses sell for what? A couple of bucks a piece. You get maybe 4 or 5 of them for $10. Just before the last eclipse 4 years ago, scalpers were selling these on the internet. Yeah, we have eclipse glasses. You can have one for 25 bucks, for $30, and people were paying. My goodness, it was amazing to me that they would. But that's what people do in this American society of you're trying to make a buck and make a buck as best you can. So again, if you can get your hands on eclipse glasses, that would be the best thing. Now, we saw what happens when the moon is too far from the sun, as is the case on Thursday, where the shadow misses the Earth. But then there are times when the moon is much closer to the Earth and casts its shadow onto the Earth, creates that blotch of darkness like it did in 1999 over Europe, creates that blotch and creates a zone of total eclipse. I don't know how many of you are of a certain age like I am, but when I was a teenager back in the 1970s, in fact, the date was March 7th, 1970. It was a Saturday afternoon. We had the path of a total eclipse of the sun come through Mexico and up along the southeast coast of the United States. It then went out to sea at Norfolk, Virginia. Look how close the path of the total eclipse came to New York, 75 miles. Look how close it came to Montauk Point on eastern Long Island, maybe about 35 miles. Now, I know that if my grandfather or if my mom, if I asked her, let's go to see the eclipse, they would have gotten in the car 75 miles. What's the big deal? But we had a car. We didn't have a boat. And so because of that, I missed out on that total eclipse of the sun. And it was big news. The next day, in the places where the eclipse was total, front page story of the New York Times. And for people like these Boy Scouts in Coney Island on the day of the eclipse, well, 96% of the sun was covered. So millions watch eclipse in clear sky, and eerie twilight falls briefly here. Because again, with 96% of the sun covered, with that much of the sun covered, it got kind of dusky in the middle of the day. Weird sight to see the moon when it covered the sun the most during that eclipse. Oh, how I wish we would have another eclipse like that, because that was really something special to see. How I wish that we could somehow manage to wave a wand and have this eclipse return to wait a minute. Remember earlier in the talk, I mentioned that cycle, that one cycle. It was what? The Exoglimos, the triple Saros, the turning of the Saros wheel. Remember that number? 54 years and 32 days. In this case, it's more like 31 days. But 54 years. Let's see. The eclipse was in 1970. So let's add 54 to 1970. That's 2024. That's only 3 years from now. And 1 month plus 1 day. It was March the 7th in 1970. In 2024, it's going to be April the 8th. And look at the shadow track. Look how it comes up across the southern United States. Right here where that star is, 4.5 minutes of total eclipse. That's amazing. It gets a little bit less as you go to the north along the path, 3.5 or 4 minutes, but still a great eclipse. And look at the areas where it's going to go over. Texas, Oklahoma, Arkansas, Missouri, Indiana, Illinois, Kentucky, the Ohio Valley, Northwest Pennsylvania. And look, the last time in 1970, remember, the track of the eclipse was out over the ocean to our east. Couldn't get to it. But now in 2024, the return of this very same eclipse, a little bit shifted to the west, to our west and north. We can get to the eclipse track now with a car. Look at this. Look at this map. These circles are the footprint of the dark blotch, the dark shadow that'll move across the Ohio Valley and up into the Empire State of New York and finally off into New England. Look at this. It comes to us. This is going to be an eclipse for the Empire State of New York. And take a look right along this blue line is where you'll be able to see the sun in total eclipse for up to 3 minutes and 45 seconds. Buffalo. Do you know that the Chamber of Commerce of Buffalo is going to use this eclipse to try to lure you to come to Buffalo? Now, quite frankly, I don't know anything that would lure me to come to Buffalo aside from a total eclipse, but they are in the middle of the totality path. And hopefully, if they are still not seeing snow, maybe, just maybe, they'll get a good view of it. Rochester, New York. Watertown. How many of you are Harry Chapin fans? Harry Chapin once said that he visited Watertown one afternoon. He said, I spent a whole week in Watertown one afternoon. Didn't think much of Watertown, I guess, but certainly it's worth going to Watertown to see a total eclipse. Plattsburgh, a college town. And on the edge of the eclipse track, the edge of totality, Belmont, Penn Yan, Syracuse just inside, Rome, New York just outside, Ticonderoga. You could walk to totality from these places. Now, down here in the Hudson Valley, we are going to see 93% of the sun covered. And you say to yourself, oh, Joe, that's 93%. Yeah, that's a good thing, isn't it? I mean, it's great. Why don't we, I think maybe I'll stay here and watch it from my backyard and see it. That's good, right? Wrong. I mean, my question to you is, should you book or travel to a place? It might be in New York State. If it's cloudy in New York, maybe you might want to go somewhere else, like Texas, or like I said, Arkansas, or Illinois, Indiana. Should you book to go to a place where the main event, the thing that you are looking to see, lasts no more than 3 or 4 minutes? Yes, you should, because you're going to remember those 3 or 4 minutes for the rest of your life. I remember the last eclipse was in Kentucky, and I spoke to somebody who was from Kentucky, and he said, I don't understand why you folks here, you astronomers, you scientists, are getting all worked up about this eclipse. It's only going to last 2.5 minutes here in our state. What's so exciting about seeing something that's only going to last 2.5 minutes? And I said, you're right. You're absolutely right. On the other hand, why do you folks get so worked up on the first Saturday in May when you go to a place called Churchill Downs to watch a horse race that lasts about 2.5 minutes? 150,000 people come. He saw the reason for, he said, yeah, well, I understand now. I understand. Folks, Hudson Valley, Interstate 87, 3 hours on I-87 up into the eclipse path. That is what you got to do. Because as beautiful and as interesting as the eclipse is going to be this Thursday morning when it comes up looking like a crescent, oh my goodness, the total eclipse is the thing that's so phenomenal. The moon slowly moves between us and the sun. At first, just a small bite. Then the bite gets larger and larger. The sky begins to dim. You know why this moment was so terrifying to early man. Now the moment comes when only the blinding crescent edge of the sun remains. The last little bit of sunlight then shines through the craters and mountains on the moon, a diamond ring in the sky. And shortly after that comes the great cosmic vision of a lifetime, a total eclipse of the sun. Only the outer atmosphere, the corona, the incredible halo of light flashing around out into the heavens, accompanied by ruby red tongues of hydrogen gas called prominences. Now I'm going to play you a snippet, a small snippet of an audio tape that was made by a man who I love very, very much from a professional standpoint. His name is Fred Hess. Dr. Fred Hess, for a long time, he was a senior lecturer at the Hayden Planetarium, one of my mentors in astronomy, and also a great teacher. Fred got the Chancellor's Award in New York State for his teaching. He taught physical science at Fort Schuyler, SUNY Maritime College. That's right underneath the Throgs Neck Bridge. In 1979, Fred took his physical science class to Lundar, Manitoba, where they were going to see in Canada a total eclipse of the sun. The eclipse lasted a couple of minutes, and the event in question took place in February when the temperature was 30 degrees below zero. Nobody felt that cold weather. Everybody was gaping into the sky at this incredible, amazing sight. Fred had seen several total eclipses before, but he got very, very excited like all the rest. And now I'm going to play you that tape and try as best to replicate that amazing sight, a total eclipse of the sun.
Hey, diamond ring! What about diamond ring? The Beautiful. Hey, look at the prominences. Anybody with binoculars, look at the prominences. They're absolutely fantastic. Yeah. Right. Look at the red all around. Look at the red. Take a picture. Take a look. Look at those streets through that corona. Oh my God. Oh my God. Those prominences are rising up to 100,000 miles from the sun. All right, here we go. Here we go. Now it's time to put it on, though. Put the filters on again. Put the filters on. Did you see those diamond rings? Oh, yeah. How about that? Look over there. There goes the shadow. Look at it. Everybody see the shadow. Look at it. Three cheers for the eclipse.
Well, folks, I think you can get the impression, regardless of whether you're a professional astronomer or a neophyte sky watcher. These are precious moments when people who see this speak of a total eclipse in awe. On that second Monday in April in 2024, an estimated 36 million people live within that totality path and will have a chance to see this event for themselves. But as we are seeing now, ultimately the cosmic sequence reverses itself. The sun flashes back into our sights. The total eclipse is over. Most people, unfortunately, probably will never see another one again. So when is the next one that's going to come here to the Hudson Valley, to New York? Here is the front page of the New York Times, January 1925, January the 24th. Front page is the next day, the 25th. My grandfather told me stories about this because he saw this when he was 16 years old. My grandfather, I'm of Italian heritage, and so my grandfather told me that his father, my great-grandfather, Pasquale, my grandfather's name was Mario, they lived in Brooklyn, and the eclipse was only going to be visible north of 96th Street. The total eclipse was going to be visible. Anywhere south of 96th Street, the eclipse would be partial. You had to go north of 96th Street to see this as a total eclipse. So my grandfather, his father woke him up and he said, "Come on, we're going on a great adventure." And my grandfather said, he was again 16 years old, "Where are we going, Papa?" He said, "We're going on the subway and we're going to go visit an exotic land." And my grandfather said, "Where's that?" He said, "That's the Bronx. We're going to the Bronx to see the total eclipse," as the newspaper said. And as you could see, skyscrapers in Midtown Manhattan blinking in empty streets. The streets were empty in Midtown and Lower Manhattan. Everybody took the subway. Everybody went north of 96th Street to see this fantastic sight, except the mayor of New York, Mayor Hyland. He decided he was going to make a political speech, and he was going to do it on the steps of City Hall. "The sun may be in eclipse," he said that morning, "but New York, never." I think there were 4 people who heard that speech. The rest of Manhattan and the rest of the city, again, was well to the north. So this was 1925. Now the good news and bad news. First, the bad news. The next time we're going, on average, for one specific site or place on the surface of the earth to see a total eclipse happens once in 375 years. So you say to yourself, "Oh my goodness, this is 1925. The next one is going to be in New York, probably will be in the 23rd century. But you're wrong. You don't have to wait that long. I'm here to tell you that if you want to stay here in New York and wait for a total eclipse of the sun to come to you, you don't have too long a wait. It's going to happen, mark your calendar, on Tuesday morning, May 1st, 2079. And you can see, here's the eclipse track. Look at this. Look at this. The eclipse track starts right over New York. Do you know what that means? That means that at sunrise on that morning, the sun will rise. Now, I know what we're seeing on Thursday morning with that crescent sun, going to be an amazing sight. But in 2079, the sun is going to rise looking like this. It will rise in total eclipse. Amazing, spectacular, wonderful, and it's only going to be 58 years from now. So, as I finish this talk, I say to all of you, stick to your vitamins, do a lot of good wishing, but, well, so it goes. If you have a chance, certainly in 3 years when it comes to you in upstate New York, try to see that total eclipse of the sun. If not, you're going to have to do some traveling around the world. I have seen 12 total eclipses, and I've traveled to places such as Turkey and Colombia, South America. I even took a trip on a plane over the North Pole. I warn you now, when you see one of these for yourself, a total eclipse of the sun, it is exceedingly addicted, more so than cigarettes. Once you see your first, you will say to yourself, I've got to see another one. I saw my first in 1972 when my grandfather took me up to the Gaspé of northern Canada to see an eclipse. And again, I've seen many more since. And again, maybe some of you will become addicted as well. So I thank you very, very much. And again, if you have any questions, I'd be very, very happy to answer them.
We're not getting questions. We're getting more comments from people who loved it and how happy that you made them. They were laughing. So I think there's everything you covered. Your stories were fabulous. Thank you. So
and I dedicate this talk. I mentioned, and you heard him on the tape, to Dr. Hess.
okay.
Dr. Hess would give talks, would give lectures at the planetarium. We all gave lectures. I have to tell you, we all gave lectures at the planetarium. And when the show was over, everybody politely, yeah, that was it. Thank you very much. When Fred gave his lectures, it was almost like he got a standing ovation. And I stopped him one day and I said, Fred, what's your secret? Tell me your secret. How do you do it? How do you get that kind of reaction all the time? And he told me, and I never forgot this, and I have been practicing it ever since. He said, Joe, actually called me Joseph. Joseph, he said, never, ever lecture. He said, if you're a teacher, the worst thing you could do is lecture. He said, you know how you do it? You tell a story. Tell a story. The best teachers are the best storytellers are the best teachers. He said, that's how you do it. And ever since I heard those words, I've practiced it, and it has worked for me. It worked for Fred. And every time I do a talk like this, I dedicate it to Fred. He passed on in 2007, but I carry his memory with me whenever I give a presentation. Even when I used to do News 12, there was a little bit of Fred, because Fred used to do the weather on Channel 11 back in the 1960s. And so I used to watch him. So everything that he used to do, I try to shamelessly copy.
Well, you learned well. You learned well.
Thank you.
There is a couple of questions. How do you make a shoe box so you can view?
Well, you could do
they
that.
Go on the net?
You could still do that, not necessarily with a shoe box, but let's say a large box, and you take a hole with maybe an ice pick and punch a hole on one side. And then the thing that you have to do is you have to maneuver it so that the sun shines through the hole. You have your back to the hole, and then the sunlight, that little bit of sunlight that's shining through the hole, falls on the other side of the box and should be the shape of the sun. It's what you call a camera obscura. And in fact, the camera obscura turns everything upside down. So the crescent, as you saw, will be at the bottom, but in your shoe box or in your box, you'll see the crescent up on top because the image is turned around.
And the next question is, the moon is a 5% rotation from the Earth or 5% from the sun?
It's 5% from, it's tilted 5% from the Earth. So if you can imagine like a record album, and hey, they're coming back. The CDs are going out, the record albums are coming back. So pretend the sun is in the middle of the record album, and the Earth is moving around that sun on that record album, on the same plane as the record album. And the moon is not on the same plane. It's tilted up. As it orbits the Earth, its orbit is tilted just a little bit, like 5 degrees. And that's just enough for it to be a little above the sun or a little below the sun. But every once in a while, it'll come in alignment with the sun at the time of new moon to cause an eclipse. And that situation is going to transpire early on Thursday morning.
Okay. So I thank you all. Thank you all for coming. Alexa, did you want to say anything? No, I think she's okay. So thank you
No,
all for
all is
coming,
well.
and we hope you will visit our libraries, visit our websites, chappaqua.library.org, greenberglibrary.org, and Mount Pleasant Library.
MountPleasantLibrary.org. Yes.
Yeah.
I will
Check
be,
the
and I
hours because we're open.
and if you extend the invitation again on, maybe I could talk about weather or any other subject or facet about space or astronomy. If you extend the invitation, I will be here, and I thank you. I thank you so much for extending the invitation today, because as you could tell, this is one of my favorite subjects, and especially with an eclipse coming in a few days from now, I love to spread the word and tell everybody to get out and take a look.
You're passionate about it.
Yes.
Did you want to say something, Alexa? No. Okay. So thank you all for coming. I will end this meeting, and thank you, Joe.
Thank you.
I'm sure we'll be in touch. Bye-bye.